Hi friends! Today we'll examine some universal schemes that will turn off the charger when the battery is fully charged. In other words, with these schemes you can build an automatic battery charger or modify the other function at industrial chargers. But want to clarify one point. If the battery charger operates on the principle of stable current, stable voltage, it makes no sense to use such function. In that case, during the battery charge the current in the circuit will fall, and at the end of the charge becomes zero. By the way, the next video will be about such type of the charger. Schemes that we examine today are designed to work with automobile lead-acid batteries, but they can work with any chargers, without any remake of these chargers. Let's start with simple circuits. The first is built only on the one transistor. The switching element is a relay with coil voltage of 12 volts. The resistive divider of variable resistor sets the desired biased voltage at the base of the transistor, will open and supply power to the relay coil. As a result, the relay will activate it and disconnect its contact, which in a state of rest was closed and through which the charge current flows. Using a variable resistor, we can adjust the voltage at which the transistor will activate. To configure this circuit is convenient to use a regulated power supply. It is necessary to set at the voltage of about 13.5 or 13.7 volts, which is equivalent to the fully charged car battery. Then slowly rotate the variable resistor to achieve transistor operation, and therefore the relay too. Now check the circuit again. For example, at the beginning of charging the battery voltage is 12 volts. As the charge increases and reaching the threshold of 13.5 volts, switch is activated and turned off the charger from the mains. By the way, the relay could be connected in another way. In this case, the charger isn't disconnected from the network, but simply lost output voltage and the charging process will stop. But the relay must be rated for currents of a half time more than the maximum output current of the charger. The transistor may be any reverse conduction. I advise you to take medium powered transistors such as BD139. The diode in the emitter circuit is also not critical. Circuit current consumption is only 10 or 20 milliamperes. But the scheme has several disadvantages. First is low noise immunity, because of which possible false operating of relay. Second is low accuracy due to lack of voltage reference and other stabilizing components. Adding to the base circuit the Zener diode will solve these problems, and we will be able to more accurately set the correct operation voltage. For adjustment, I advise to use multi-turn trimmer. Diode VD1 protects the transistor from self-induction of relay. Setup of the circuit is similar. The lamp simulates the charging process and connected instead of the battery. When exceed a certain threshold, the relay is activated and the lamp goes out. The second scheme is based on the popular timer NE555. Incidentally, the Chinese made this scheme with some modifications and put into mass production. The description below video includes links to purchase such device. NE555 includes two comparators. The reference voltage set by Zener diode. Threshold is set by trimmer. As soon as the battery voltage is equal to the threshold, the timer output becomes to a high level. Thereby, the transistor will work. In both schemes, a threshold can be set in the range of 13.5 to 14 volts. Fully charged car battery voltage is between 12.6 to 12.8 volts. But when engine in operate, voltage reaches 14.5 volts, so that little recharge doesn't hurt the battery. A similar scheme can be made on the basis of the comparator chip or operational amplifier, which used in the comparator mode. The principle of operation is the same as in the case of NE555 timer. In this video I showed only the most simple and affordable options, and hope it was useful for you. The first link in the description will download the complete file with all boards and circuits. There are also links to purchase low-price chargers and cutoff systems and other useful information. Please don't forget to rate video, share with your friends and subscribe. Goodbye, we will meet again soon. With you was Aka Kasyan.